Okay, Bismillahirrahmanirrahim. We have so far discussed that how do we simplify the search, like if you have under root 8, so you must be able to write it as 2 under root 2, or if you have, let's say, there is maybe um, 45 square root of 45, so you can write it as 3 under root 5. And then we have seen how to add, subtract, or multiply uh, the surds, okay? And now out of these, one thing is very important, that, for example, if there is 2 under root 3 and minus 3 under root 2, and there is a square on it, so we should know how to apply this square. So this is a square minus 2 into a into b, and then plus we have the b square. Okay, now this 2 under root 3 square has to be 4 times 3, this is 12, and this is 2 2s are 4, 3s are 12 under root 6, and this one is 9 2s are 18, so we can write it as 30 minus 12 under root 6. Similarly, if this was plus here, so this term would be plus here, okay? And then the third algebraic identity, like if suppose you have under root 5 minus 2 under root 2 times under root 5 plus 2 under root 2. So we should be, rather than expanding, we should be doing it like this: under root 5 square minus 2 under root 2 square. So this is 5 minus 8. So that is equal to minus 3. Now we have to look at the cases where we have to go for the division, okay, and where our divisor might be a surd. Now, just to start with, now let's take an example of, suppose I have 5 over under root 2, okay. We have to divide 5 by under root 2. So since this is an irrational number, so this division uh, is not like when you have 5 over 2 and divide it like this, you write it as 2 whole 1 over 2. So the only way of dividing this 5 by under root 2 is just to rationalize the denominator. We have to change this denominator from an irrational number to a rational number. In other words, we have to get rid of this third form over here. Now this is a fraction. We cannot just square it, okay? So using the concept of equivalent fractions, we can multiply and divide with the same number. So we shall be multiplying the numerator and denominator with under root 2, so that we get rid of the square root from the denominator. Okay, Waleed, you can ask me if you feel anything which is going beyond your imagination or your understanding or your concepts. Okay, so this is 5 under root 2 over 2. So now once the denominator has been rationalized, so this division has been completed. Now suppose you have under root 7 over under root 5 maybe. So you need to multiply this by under root 5 over under root 5. So this is under root 35 over 5. That's it. Okay. Suppose you have 3 over 2 under root 5, let's say, or under root 3. Okay. 3 over 2 under root 3. So you just need to multiply this with under root 3 over under root 3, because we want to get rid of this square root from this 3. So that will be 3 under root 3 over 2 into 3. That will make it 3 under root 3 over 6. Okay. Now, we also have the cases where we can have something like, let's say this is 5 over under root 2 plus 1. Now, these are two terms, okay? So, if I multiply this with under root 2 plus 1 and over under root 2 plus 1, you will see that but I will be getting under root 2 plus 1 whole square in the denominator. So this will give me 2 plus 2 under root 2 plus 1. So this is 3 plus 2 under root 2. You see that this square root is still there, okay? So this will not work. Yes, if we multiply this with under root 2 minus 1 over under root 2 minus 1, rather with this plus over here, okay? So this will uh, serve our purpose. This is minus 1 and this is minus 1. Now, why are we changing the signs? Because we know that if it is under root 2 plus 1 times under root 2 minus 1, so there will be square on both of them. So that is why we're doing it. This is 2 minus 1, so this is going to be 1. So the third form is gone. So to if you have two terms over here in the denominator and you still want to rationalize the denominator, so you have to keep a difference of the sign between these two terms. So this will give you 5 under root 2.
Sir, could you please repeat how we could change, like when we should change the signs?
Yeah, this is, you will always be doing, Walid, whenever there are two terms over here. Okay. Uh, Let me give you one more example over here. Now, suppose you have under root 3 divided by under root 5 minus under root 2. Okay. So instead of multiplying it with the same under root 5 minus under root 2, I have explained that why don't we do this? Look at this. This is under root 5 minus under. If I use the same thing, see what will happen. This under root 5 minus 2 into under root 5 minus 2 means under root 5 minus under root 2 whole square. When you expand this, you have 5 minus 2 under root 10 plus 2. This is 7 minus 2 under root 10. You see, there is still this third form in this expression. So this will not work if you keep multiplying with the same denominator over here. So you will have to change the sign between them so that you can apply the fact that a plus b into a minus b is equal to a square minus b square. Uh, you also know that when there is a third form, so this square root can easily be removed if you have a square on these terms. So the squares can only be achieved if you multiply them with a different sign, so that you have this thing happening here, a plus b times a minus b. You got it? So to have the different, uh, to have the squares on these individual terms in the denominator, we have to use the identity a plus b into a minus b. So you will switch the sign between these two terms. Okay. Now this numerator, this under root 3 into under root 5 will become under root 15, and this under root 3 into under root 2 will become under root 10, and down here you have under root 5 square minus under root 2 square. Okay, this is under root 15 plus under root 10 over 5 minus 2. Yes, the moment your denominator is a rational number, that means the division has been completed. Okay, let's take an example here. Suppose you have to rationalize the denominator, you have 9 over under root 3 minus, let's say, 2. Okay, can you do that? Walid, how should we start this? Yes, I should
Sir, multiply
yes,
under root 3 plus 2.
over under root 3 plus 2. Okay, so this is 9 under root 3 plus 18 over, this is under root 3 square is 3 minus 2 square is 4. So this is minus into 9 under root 3 plus 18. That is how this division has been completed. Okay, now can you try this? Suppose if you have, now I'm just going to write some questions for you from the add math book. You just try them. You rationalize them. Okay, so you give it a try, and then I'll tell you what are the correct answers for these. Okay, now see my working, and then you can check your work. So since we had the square root of 3 here. So this is 6 under root 3 and this becomes 3. So your answer is 2 under root 3. Okay. So the next one, we have to multiply this by under root 2 minus 1 over under root 2 minus 1. So the numerator is 3 under root 2 minus 3. The denominator is 2 minus 1. So this is simply 3 under root 2 minus 3. This one, we shall multiply this by 2 under root 3 plus 3 over 2 under root 3 plus 3. So you have it as 16 under root 3 plus 24. And this 2 under root 3 square is 4 threes are 12 minus 9. So we have this 16 under root 3 plus 24 over 3. That's it. Okay, for this D part, you will be multiplying this with 2 under root 5 plus 4 over 2 under root 5 plus 4. So this is going to be like this into this will give you 24 times 5 is 120. And then you have plus 48 under root 5. Down here we have this square is 4 5s are 20 and then minus 16. So you see you will be getting 4 from here. So this is going to be 120 plus 48 under root 5 over 4. So if you take a 4 common from here and that can be cancelled with the denominator, you can do that simplification. So you are left with 30 plus 12 under root 5. Getting this, Waleed? Yes?
Sir, could you please repeat this question?
Look at this. We just multiplied by 2 under root 5 plus 4 over 2 under root 5 plus 4. Okay. Now 12 under root 5 times 2 under root 5 is 24 times 5. This gives you 120. So we have this 120 here. Then 12 under root 5 into 4 will give you 48 under root 5. Okay. Then you have the squares on them. 2 under root 5 square is 4 times 5. That will give you 20. So that is why we have 20 here, this 20. And then 4 square is 16. Okay? Yes, Waleed?
Ji sir, okay.
Okay. And then I just written this 20 minus 16, 4 over here. If you want me to write it like this, like if I take 4 common from the numerator, this becomes 30 plus 12 under root 5 over 4. So these 4s are cancelled. So you get this answer, which is 30 plus 12 under root 5. Okay. Now for this one here, you will multiply this with 3 under root 2 minus 4 over 3 under root 2 minus 4. Okay, so yes, so this is minus 1. So this into this gives you 9 into 2. And this into this will give you minus 12 under root 2. And down here you have 3 under root 2 square minus 4 square. Okay. So this is 18 minus 12 under root 2. This is 4, 9 into 2 is 18 minus 16. This one is 18, this one is 16. So this is going to be 2. And is there any simplification here, Mali? Yes?
Yes, sir.
You can just assume that 2 is taken common, so the 2's are cancelled. So
Yes.
this answer would be finally 9 minus 6 under root 2. You must do this simplification wherever you can, okay? Now for this last one, we have here, this is times 3 under root 5, 3 under root 3 plus under root 5 over 3 under root 3 plus under root 5. Okay, so we have This into this is 9 under root 15. And this into this is 3 into 5, that is 15. This into this is minus 6 into 3 is minus 18. And this into this one is going to be minus 2 under root 15. And down here we have 3 under root 3 square minus under root 5 square. Okay, so after simplifying it, we are going to get to, so we get that is equal to this 9 under root 15 minus 2 under root 15 is 7 under root 15 minus 3 over, this one is 9 threes are 27 and this is just 5. So we have 22 down here and there's no further simplification. So this is what we say, what we call the um, rationalization of the denominators. Okay, so that's it from today, man.